links, it automatically opens your default browser, logs you in, and takes you right to the page you want. So that's kind of interesting, right? Because you now have a fat client application that somehow knows session data that gets transferred back and forth between the front end website. So that's definitely something you'd want to look for. Also, too, if I have my blog at the end of the thing if you want to find out about predictable resource locations as well with cloud apps. Hulu, who actually, first of all, who uses Dropbox in here other than me, or who will admit to using it at least? All right, a few people. All right, very good. I haven't found anything devastating yet, but I haven't really looked either. So, I mean, I encrypt stuff, some of the important stuff before I go to it. How many people have at least heard of Hulu or watched Hulu? Anybody use Hulu Desktop? Okay. So at first, Hulu Desktop looks like kind of a fat client application, which I guess you could kind of say it is. But if you download Hulu Desktop and then you kind of inspect the traffic, it's basically just making a call for a Swift file. So it's just huludesktop.swift. So those are kinds of things to keep in mind too when you're analyzing, clients that connect back to web apps. How is that content being rendered on your system, and how can that be violated? So who here uses Pandora Radio? Wow, I expected that to be a lot higher than Hulu. Wow. Well, Pandora, they typically have a fat client application. Well, kind of a fat client application. It's an Adobe Air app that if you subscribe to their Pandora One service, they'll give you. And I didn't do that, but for OS X, there's a program called Pandora Jams. So I was kind of interested at how that talked back and forth to the Pandora service, and that's really easy to find too. You just light up Wireshark, and then you can see it's passing data back and forth with XML. So that's kind of some of the ways you can identify the structure of calls, analyze any kind of client-side functionality. So for something like Pandora, there's different functions you can take advantage of through a quote-unquote fat client application, and it sends it back to the web server. Adding a playlist. Well, logging in is the huge one. Adding a playlist, searching for different artists, things like that. So let's bring on some fail. I found that last night, and when I was thinking of how early it was going to be, and maybe there's a couple laughs that needed to be had. So I just, I don't know, I can't go past this slide for a second. It's just awesome. When thinking about how external content is rendered into a canvas, it can be very bad. So this is an actual older screenshot as well of the social network MySpace, and how they handle content segregation is they're basically like, we don't want you touching our stuff, but you can touch your own stuff all you want. And oh, by the way, you can touch other people's own stuff too. So they have this api.msappspace.com domain where they just shove all of their applications, which is really fun if you're an attacker, because it used to be really easy to become a MySpace developer. You just ask them, and it's cool. So, and I think to this day I still have a developer account, which was really bad after Black Hat when they all came up to us. But anyway, you can call other built-in functions from other things that are rendering on the same canvas. So depending on when things are rendered in the browser, but definitely cookie information. So this screenshot is me calling a cookie that was set in another application called pants status. Now, I was gonna write this application called pants status because me and Sean Moyer were talking about how funny it would be to have an application called pants status, and it would just say currently down for maintenance, it would never work. So pants status currently down. But then I was talking with Sean last night, and we thought that maybe it would be fun to have it and then say currently on the ground, but I don't know. If you have shared APIs, be aware that they can be violated and turned into an anonymous proxy. So if you have these consumption APIs that grab external content and then are rendered for users, you can also use that and not care about the rendering whatsoever. So a while back when I was looking at OpenSocial, I found out it was very easy to call other people's APIs. So it was rather fun one night when I was seeing like how many I could call at once. So like I would call one from like MySpace, and then I would get it to call friend feed, and then I would try to get it to call, other things, and they were actually working, which was kind of crazy. But you could, if you had some form of data you wanted to send somewhere, and obviously your mileage may vary depending on the API. So you may be dealing with APIs that are developed in-house, and there's not a framework that's been adopted. So when a framework's been adopted, obviously fixes get integrated really quickly. And what that would look like is something like this. So you would see an API call, and this is high five. And a lot of these are open social because it's really easy to understand. So like standard HTTP GET. So you'll see something in here that says URL equals target and HTTP method equals GET. So if you place things in the URL equals target, as long as it's properly encoded, which this example isn't, as long as it's properly encoded, it will just send data because it's a proxy function. So it's going to do what you say. Proxies are very helpful because they go do things for you that you ask them to. It's like, please send crap here. Okay, thank you. I will do that. What else is really fun is if you change the location to 127.0.0.1, you find very interesting results. This is the localhost dev page on the proxy box that was making the function. Where this becomes really interesting is now you have a machine that is making calls for you that's behind any kind of filtering devices. So other machines, if you, like for instance, if I wanted to know the public IP address of this proxy box, I could call whatismyip.com and it will return its public IP address. From there, maybe there's other subsequent public IPs that are right next to it, or you can try to enumerate through private IP addresses too, which obviously becomes a lot more fun. And there may be some sort of trusted connection between this box and something else, which there shouldn't be. It's a proxy box. But, actually, it would never happen, right, because everybody does things properly. So with this call, when you're calling things like 127.0.0.1, there's nothing saying that you can't add a different port number onto this as well. So, hey, that can be a lot of fun as well. And there's nothing saying you can't add other ports for other systems behind that as well. So it would be really easy to script something together, and I have done it in the past, that will go through and check for different ports and check for other public and private IPs on the same network. Oh, and just as an example, I'm doing everything here is unencoded for just ease of on your eyes, because it looks really crazy when you start encoding things. So that's the other thing about understanding what the API is expecting. Because if you're asking it to try to bring back something that's semi-legitimate, you need to know how to tell the function to return it for you. So the URL equals, if you remember in the example before and then in this one, the URL is encoded in some way, shape, or form. So you might end up with something that looks like this. So you just need to decode it and find out what it's calling. These are also fun. These are API direct loops. So it's possible to get APIs to call themselves over and over and over again and never stop, which can be a lot of fun. And what's funny is sometimes these things are thought about. So like Google with Open Social they're like, well, they had this figured out with browsers a long time ago. Like you shouldn't infinitely follow redirects because that's just ridiculous. So they kind of thought, well, in our proxy functions, we probably shouldn't follow more than 7 redirects because that's just ridiculous. However, if you make the API call itself again, it's only 1 redirect. So yeah, obviously they didn't think about that scenario. And for every subsequent API call, there isn't a redirect at all. So if I have API A call API B, there's no redirect there. The only redirect that would happen is when it gets redirected back through the loop again. And what that looks like is something like this, and this is unencoded as well. But there's nothing saying that the API just can't call itself over and over and over again because the API never sees the redirect. There's never a redirect there. So yeah, that's bad news. The only thing you're really limited by is the length of the URL, and if your browser cacks, or if there's something in the API that restricts the length of the URL. But if there's one redirect in that loop and you're not violating any of those, it'll just keep going and going and going, which is always fun. So I'm going to talk about a couple of examples from 2009 where people just are doing it wrong. Okay, I got 15 minutes. Does anybody remember this OAuth session fixation vulnerability?